Hello and welcome. Let's go ahead and talk about what to expect for our upcoming exam. All right, so let's go ahead and talk about what the exam is going to cover and some other important things to keep in mind for the exam. So our exam is going to cover our material on chapters 1 and 2. Chapters 1 and 2. And let's actually start by just going through and listing off the different sections, and then we'll talk about what the content was in each of those. So for the sections, we have 1.1, 1.2, 1.3, 1.4, 1.5, and then we skip 1.7, 1.8, and that's for chapter 1. And then for chapter 2, we have 2.1, 2.2, 2.3, and 2.8 and 2.9. That's what we're looking at so far. And let's talk about what material were in each of these sections. So for 1.1, we had systems and linear equations. For 1.2, we had row reduction. We'll talk about these after we're done writing them down, but let's just jot them down. Row reduction and echelon forms. 1.3, we had vector equations. We also introduced the notion of span in the section as well, so I'll include that. 1.4, we have the matrix equation, abbreviated equation EQ apostrophe N, the matrix equation AX equals B. In 1.5, we have solutions of linear systems. But in particular, we were talking about homogeneous systems. Which would be AX equals the 0 vector. On 1.7, we had linear independence. And we can't really have a conversation about linear independence without also talking about linear dependence. And in 1.8, we talked about linear transformations. Moving on to chapter 2. Now 2.1, we talked about matrix operations. Really introducing a lot of the foundation for what we're going to go with next with working with matrices, right? Talking about multiplying, arithmetic with matrices. And then in 2.2, we started talking about the inverse of a matrix. In 2.3, we talked about invertible matrices. And introduced the invertible matrix theorem, IMT, for invertible matrix theorem. In 2.8, we talked about subspaces of Rn. And in 2.9, we talked about dimension and rank. Dimension and rank. And let's go through and just the idea is for this to be a short video just to refresh your memory on the things that we've discussed. So I'm going to try to keep this as a short video, but let's go back through and let's talk about each of these individually just to get a very brief recap. But if any of these feel sort of foreign to you or you're not quite sure, definitely go back and rewatch those lecture videos for sure. So in 1.1, this was really an introduction to the course, right? Talking about how we can take a system of equations and how we can write it out into coefficient matrices, augmented matrices, how we can introduced the idea of solving. We introduced some very important questions. First and foremost, with a system, is there a solution? And then a follow-up question, is that solution, if it exists, is that solution unique? So a lot of very important ideas, but really the foundation for what we're talking about for the semester. So think of this as your intro section. This was an introduction. And 1.2 sort of follows suit with that. Very important for us to understand what it means to be, in that fully reduced row echelon form. And when we're talking about solving or working with matrices, I really want to encourage you to always go that extra step to find that fully reduced row echelon form. That's going to be very important for us for our course. So as you're going through row reduction and practicing for the upcoming exam, don't stop shy of that. Keep row reducing. Get to that fully reduced row echelon form. Make sure you know what that means, all of the sort of different characteristics of what it means to be in an echelon form versus a fully reduced row echelon form. So very important. So these two sections to start with really sort of give us a lot of the backbone of what we're going to need. And then some of that seeps into 1.3, where we just start talking about vector equations and arithmetic with vectors and introducing the key idea span. So really in these first three sections, we have a lot of introduction to the course, a lot of very important things that are going to come up over and over again routinely. So very important. And important to understand what span refers to. We talk about that a lot, even up through now, talking about subspaces, thinking about spanning sets and things like that. Very important to be comfortable with these ideas, these key terms, what it means, the notions behind them, all of that. 1.4, we started really getting interested in solving, right? We have the matrix equation AX equals B, talking about solving using an augmented matrix system. Taking A as the coefficient matrix and then augmenting with vector B, using row reduction to solve, trying to keep in mind when we can solve, when we can't solve. In 1.5, really focusing on the homogeneous system, AX equals the zero vector. And remember, we had a very important question with this. We want to know, does a non-trivial solution exist? Because with AX equals the zero vector, certainly if my vector X is also the zero vector of appropriate size, there will be a solution. So a homogeneous system is always consistent. There always is some solution. But we're really interested in knowing, well, okay, if I always have a trivial solution, is there some non-trivial solution that's going to work as well? And that was a big question for us when talking about the homogeneous system AX equals the zero vector. We switch colors so I don't end up sort of writing over some of my notes here. Linear independence in 1.7 was another very big topic for us. Remember, if I have a set of just two vectors, it can be pretty quick to determine, because in order for them to be dependent, they have to be direct multiples of each other. But as soon as I start talking about more vectors, right, if I have, a set of 3 vectors, 4 vectors, 5 vectors, I can't really use that same trick. So what I would want to do is I would want to build a matrix, and I want to use those vectors in a set as column vectors to the matrix. And as I reduce, whatever gives me a pivot column is really representative of an independent vector that belongs to the set. So the pivot columns are really what we're looking at when we're looking for linear independence. And we talk about these ideas later on in the course when we talk about things like column space as a subspace of Rm, things like this. But very important to sort of keep that in mind. Now there are a couple things that we could be on the lookout for. For example, if a set contains the zero vector, there's an associated result with that. If I have a set where there's more vectors than entries in each vector, then we get a result from that as well. So definitely worth sort of revisiting that material and making sure you're comfortable with having a set of vectors and determining whether or not it's linearly dependent or independent. Some of them we can tell quickly. Some of them do require work where we build a matrix using these vectors as column vectors, and we're reducing to find and locate the pivot columns. And that brought us to 1.8, talking about linear transformations. Very important that you're comfortable with those properties, what it means for a transformation to be linear, and comfortable using those properties. Right? So we want to make sure that we're using those properties. Those properties are, if I have a transformation applied on the sum of vectors, that would be equal to the sum of the transformations applied on the vectors separately. So that's a first property. And then a second property for linearity of a transformation. If I have a scaled vector inside the transformation, then I can bring that scalar out as a coefficient on the transformation of the vector. So those two properties, t of u plus v is equal to t of u plus t of v, where u and v are vectors or objects. And the second property, t of c times u, where u is a vector and c is a scalar, t of c times vector u is equal to c times t of u. So I need those two properties. I have to be comfortable working with them and working with properties of vectors as well. So definitely make sure you review 1.8 if you're uncomfortable with linearity of transformations. Let me switch colors again. 2.1, the beginning of the chapter, really is a bit of an introduction for us. If we're going to talk about working with matrices, multiplying a matrix to a vector, adding matrices, all sorts of ideas like that, then we really need to talk about how these operations are defined, when they work, when they don't, talking about things like transposes of matrices, all sorts of good information here. But this is really sort of a section where we're building mechanics. We're building the mechanics so that we can then move forward with our course material and not get caught up with, well, how do I multiply matrix A times matrix B? Is it the same as matrix B times matrix A, right? All of these questions that we have to sort of, get out of the way. 2.2, we began a discussion on finding inverses of matrices, and we really started with 2 by 2 matrices. Right? And we have a nice closed form for finding the inverse of a 2 by 2 matrix. But then from there, moving on to 2.3, we started talking about this even further. We introduced the invertible matrix theorem. We started talking a bit about how we can find inverses of larger square matrices. And we saw some really interesting reduction technique. So here, for example, if I have some matrix, let's say I have a 3 by 3 or a 4 by 4 matrix, I want to find its inverse. Remember what we were doing? We were taking that matrix A, and then we were sort of augmenting it with the identity of the same size. And from there, we were going through row reduction to bring that identity to the left-hand side. And then what we were left with as a consequence of this on the right-hand side is our inverse. So a very interesting way that we can build inverses for something that's larger as a square matrix than a 2 by 2. And then thinking about the invertible matrix theorem, using properties on that invertible matrix theorem to determine, perhaps by inspection, if a matrix is invertible just by looking at it. Brings us to one of my favorite sections next, 2.8 subspaces of Rn. We have some very favorite subspaces, right? We love talking about the column space of a matrix. So column space of A, which is a subspace of Rm, vector space Rm. And then another very important subspace, we have the null space of a matrix A, which is a subspace of Rn, N for null space. We love talking about these. Thinking about building them, remember it's the pivot columns of a matrix that are going to build a subspace for the column space. So here I need the pivot columns. And I have to take this from the original matrix, right? So remember, if I go through and get an echelon form, then I find the pivot columns, I have to be taking those as column vectors from the original matrix A, not from the reduced version. So always going back to the original. For the null space as a subspace, this is actually something that was quite familiar to us. This is really just solving the homogeneous matrix equation AX equals the 0 vector. When we build that parametric vector form, so really we're building a parametric vector form, we are just stripping away the linear combination, stripping away the scalar weights, the free variables as they were, And we're just focusing on the numerical vectors that we were left with. That builds for us, when we put it in a set, a basis for that subspace for the null space. So make sure you're comfortable building these subspaces, which then brought us to our last section, dimension and rank in 2.9. So remember, when we talk about dimension, we're talking about the number of vectors in a set. And it's important to clarify and say that when we're talking about a set that just contains the 0 vector, that the dimension of that set is defined to be 0 numerically. So if I just have a set, and in that set, let's say I'm talking about vectors in R3, I have the 0 vector in R3, 0, 0, 0. We define the dimension of that to be 0. However, for a non-zero vector, so I could say the number of non-zero vectors in a set, or non-trivial vectors in a set, that's going to give us the dimension of the set. Right? And then we talk about this idea of rank. We're really thinking about our rank nullity theorem. So we can go ahead and describe that as the rank of a matrix A plus the dimension of the null space of that matrix A is equal to lowercase n, where A is an n by n matrix. So n really refers to the number of columns in that matrix. But I have this very nice arithmetic formula that I can use known as the rank nullity theorem. But in this section, we got to answer some interesting questions as well. And we also got extra practice building subspaces for column space and null space. And in addition to that, answering questions about dimension. Very important. Scrolling around. Okay, there we go. Looks good. So, what are some other things worth sort of mentioning for the exam? Well, a couple things I want to point out. No calculators. Not going to need a calculator. Don't bring a calculator. No calculators for the exam. What else we're sort of discussing? Make sure you're studying. Now, how should you study? Well, there's a few things that you can sort of consider for studying. Make sure you're comfortable with everything in the lecture videos. Make sure you're comfortable with everything in the lecture videos. If you feel comfortable with all of those problems in the lecture videos, then you're already at a good place. And a great way to sort of use that for studying, we have those blank student notes. You can go ahead and get the blank student notes, and you can try going back through those problems on your own, try to see how many of them you can solve. And that's great because if you run into any issue, then you can go back to the lecture videos and you have the complete play-by-play there. You can figure out where you're getting stuck and get an idea as to how to better motivate and direct your own personal studying. Aside from that, we do have the UBX homework assignments. And additionally, I have textbook exercises up on UB Learns. So textbook exercises. I think that these are great ways to study. Definitely, if you're comfortable with the supplemental textbook exercises, all the content in the lecture videos, you feel comfortable with the homework that we've been assigning, I think you're going to be in a great place for that exam. But just make sure that, turn every single stone over. Make sure you're comfortable with everything. If you have any questions, you can always ask me. Head on over to the discussion board. Let me know what you're struggling with. And I think that's a great way to sort of motivate your studying as well, is as we're going through, and even in this video, I just went through, I talked about all the different sections of all the different material that we've covered. You're probably thinking, oh, I remember that. Or perhaps, I don't really remember that as much. So you can go ahead and start getting an idea as to maybe where you want to budget your studying a bit more efficiently. Do I want to spend more time on this one subject? Do I feel comfortable with this other section? Maybe I'll study it, but maybe not quite as much. Maybe here's a section that I don't really remember learning too much about, or it hasn't really stuck or consolidated well. Okay, so that gives you a good idea where to start. Just some general disclaimers. And the cram session doesn't really usually work. It's not great for consolidating information is the issue. So start studying early. Make sure you break it up across multiple sessions. Take breaks if needed. Study before you go to bed. And then when you wake up, resume studying. That's really going to help sort of build the neural pathways to retrieve information. I like to give sort of the following anecdote, right? You think about if you were doing something different, let's say learning a musical instrument, if you have the option between, let's say, playing every single day throughout the week, the 5 weekdays for 1 hour a day, or on Sunday, playing that instrument for 7 hours. You'd say, well, what would be more beneficial for you on the instrument? And it's interesting to think that if you're actually using the weekdays and just doing an hour of practice time every single weekday, you're going to see a lot more results than if you're just doing the cram session of 7 hours on a Sunday, right? And even though 7 hours compared to 5 hours is a lot more, that's like over 30% more time on the instrument, well, it's not as useful, right? Even though it's much more, it's not as useful. So you really want to be breaking this up. Try to work in a way that's efficient and smart, and don't just leave everything to last minute. That's not really going to be the best representation of what you can do as a student. So I just want to sort of mention these things. Keep that in mind. Yeah, so you'll be getting tons of spam emails from me. Everything's going to be headed your way. You know who you are. And if you have any questions at all, you can always ask me. I'm happy to help. I'll be around. No matter what, I want to make sure that you come into this exam stress-free, right? So whatever you're doing, stop right now. If you're in the middle of studying and you clicked on this video, if you're just about to start studying and you're starting to, feel a certain way about it, just, work with me here. Close your eyes, take a deep breath. What is it? It's in through the nose and out through the mouth, or is it in through the mouth and out through the nose? Or is it nose and nose, or mouth and mouth? It's one of those four, right? So you take a nice deep breath. Make sure you feel comfortable, relax. Everything's going to be fine. You are the best that we have. You're amazing. You got this. I'm not even worried about you. You've been doing all the hard work. You've been putting in all of the hours. You've been doing a great job with the course material. This is your opportunity now to finally shine and to finally see some of the results of your hard effort. It's time for it to pay off, right? So I'm proud of you. You're going to do amazing on the exam. Don't be nervous. Don't be afraid of it. I'll be honest. The exam's afraid of you. The exam's afraid of you because you're going to figure out all of its secrets. You're going to write it all out. Everything's going to be perfect. So don't even worry about being afraid of the exam. That's it's the other way around. You know what I'm saying? But certainly, I want to make sure that I take this opportunity to wish you good luck. You are the best of the best. You got this. You are the best. You are amazing. And I think I speak for everyone when I say I couldn't be more proud of the achievements that you've been making this semester. Keep it going. Keep it up. Get that cup of coffee. Make sure you get plenty of sleep. Get a good night's rest. Have a good breakfast, whatever you're doing for breakfast these days. Let me know in the comment section below if you have any special tips or strategies, or let me know what you like to have for your breakfast beverage. If you're having orange juice, if you're having coffee, if you're drinking some tea, if you have milk, or if it's chocolate milk, or if it's strawberry milk, or if you got something different. Let me know what you have for breakfast. If you're having a croissant, if you're having a bagel, if you're having a breakfast sandwich, if you're having oatmeal, if you're having cereal, if you like Cinnamon Toast Crunch, if you like Golden Grams, if you like Honey Nut Cheerios, whatever you like, Apple Jacks. Why, if you like Apple Jacks, let me know why you like Apple Jacks, even though they don't taste like apples. But anyways, I hope you're doing great out there. No matter where you are and what you're doing, remember to always keep learning, keep dreaming, follow your heart. Let me know what you need. I'm here to help you. We're in this together. But good luck with studying. Go ahead and get started. And I'll be seeing you soon. Until then,